Hey everyone, welcome to Algebra 1-2, Section 7-2, multiplying powers with the same base. By the end of this lesson, you should be able to use the product rule. That's what I call this. I call it the product rule. You'll be able to use this product rule with numbers, meaning no variables. You'll be able to use it with variables. You'll also be able to use it with variables with coefficients. And you need to be able to do it with multiple variables. Okay? So let's talk about the product rule. So if I have this problem, this is what the product rule looks like. It's when you're multiplying two things and exponents are involved. So let's break this down as to what it's saying and then see if we can come up with a shortcut after we go through all that. So if I've got x to the third times x to the fourth, what does x to the third mean? It literally means x times x times x. So if I break that down and then break down x to the fourth as x times x times x times x, if I put that all together, I basically have x times x times x times x times x times x times x. So basically I've got x 7 times. So x to the 7th. Now, can you look at the original problem, look at the answer, and maybe come up with a shortcut? If you said just add your exponents, you're absolutely right. And having that visual there, that's a good way to see it so that you recognize, okay, I take all 3 of these x's, take all 4 of these x's, put them together, and I've got 7 x's. So there's 2 parts to the product rule, and that's one of them, is that you add the exponents. So let's go ahead and do a couple examples. So if I've got a to the 4th times a to the 9th, add them up and I get a to the 13th. If I've got b to the 12th times b to the 24th, add them up and I get b to the 36th. If I've got c to the negative 8th times c to the 3rd, if I add those up, negative 8 and a positive 3 makes negative 5. So I get c to the negative 5th. However, if you remember from our last lesson, you don't want negative exponents as your final answer. So I need to make that move, and my answer is going to be 1 over c to the positive 5th. Okay, 2 to the 7th times 2 to the 4th. A lot of people will look at that and say, okay, you add up the exponents, and that's 11, and then 2 times 2 is 4, so that makes 4 to the 11th. And that's not the case. Notice how each time we did it before, the base stayed the same. Okay, so we know what an exponent is. The base is just what the exponent sits on. So in the first example, a to the 4th, 4 was the exponent, and a was the base. So in all the previous examples, the base stayed the same. So in this case, that's also going to be the case where the 2 stays the same. So it's like saying I've got 7 2s and I've got 4 more 2s. So put them together, I've got 11 2s, not 11 4s. So let's try some examples that involve coefficients. So here I've got 3x to the 9th times 5x to the 7th. So I'm going to kind of break that down. Don't think of it as the 3 being attached to the x to the 9th. The 3 is just multiplying the x to the 9th. So I can visualize that as 3 times x to the 9th times 5 times x to the 7th. Okay, don't think of the numbers as attached to the variables. So when I do it like this, and I multiply stuff, does it matter what order I multiply it in? No. So I can rearrange it and put the 3 and the 5 together, and then the x's together. And so 3 times 5 is just 15. And then for the other part, add up our exponents. So the second part to the product rule is, first off, you add the exponents, but when you're dealing with coefficients, you multiply them. It's still a multiplication problem, so the coefficients act like normal numbers. You just multiply them together. So that's the 2 parts to the product rule. If there's coefficients, you multiply them. If there's exponents, you add them. So let's go ahead and do a few more examples real quick. All right, so here is an example of a worksheet. Let's go ahead and do a couple of these problems real quick. Number 1, 4 to the 2nd times 4 to the 2nd. So I'm going to add up my exponents and get 4 to the 4th. Now, if it's an easy problem like this, 4 to the 4th, we can go ahead and work that on out, because 4 times 4 times 4 times 4 is 256. Now I'm going to skip down to number 5 real quick. Here I've got 2 n to the 4th times 5 n to the 4th. So the rules that we talked about were multiply your coefficients. So 2 times 5 is 10. N to the fourth and n to the fourth makes n to the eighth. Okay? So some people want to make the distinction, well, why is it that we didn't multiply the 4s here, but we multiplied the 5 and the 2 here? How come it's different? And the thing is, it's not different. What is different is that here the 4s are acting as bases. They've got the exponent sitting right on top of it. Whereas down here on number 5, the 2 and the 5 are not bases, they're coefficients. And coefficients and bases and exponents, they all behave differently. So make sure you know what you're dealing with, whether you're dealing with an exponent or dealing with a coefficient. Okay? I will multiply the coefficients, but add up the exponents. If it's a base, it stays the exact same. Make sure you know that differentiation. Let's take a look at number 2 real quick. Here I've got 4 times 4 squared. Now visually, the first thing I see is 4 times 4, but we're not going to do that. That 4 right there is a base. So what I can do is I can add up my exponents, but if I don't see an exponent here, it's understood to be 1. So when I add up those exponents, I get 4 to the third power, which, by the way, is 64. Let's do that example on number 4 as well. So if I've got 2 times 2 squared times 2 squared, literally what I have is 2 to the first times 2 to the second times 2 to the second. If I add up all those exponents, I get 2 to the fifth, which, by the way, is 32. Okay, let's skip down to some more examples. All right, number 9. I'm going to multiply the coefficients. So 5 times 8 is 40. B to the second and B to the first makes B to the third. Now I'm hoping that you guys are finding this easy, and I want you to be able to blow through examples real quickly. So number 11, 6 times 2 is 12. X to the first, x to the second makes x to the third. What about a situation like this? What if there's more than one variable? All right, well, let's deal with that. We're just going to break this down and do one thing at a time. So first thing I want to do is my coefficients. So I will do 7 times 10 times 8, which is 70 times 8. 70 times 8 is 560. And then I'll go through and do each variable. So I've got v to the third, v to the fifth, v to the third. Okay, that's going to be, let's see, 3, 5, and 3 makes 11. So v to the 11th. And then I'll go through and do the u's. So just do one thing at a time. Even if there's a lot of stuff going on, break it down and just do one thing at a time. So u to the third, and then u to the first makes u to the fourth. So what started off as a complicated looking problem really isn't bad if you just break it down and do one thing at a time. Do your coefficients, then do one variable, then do another variable. Let's take a look at number 15. Multiply the coefficients. So 6 times 8 is 48. Then I'll do the m's. M to the third and m to the second makes m to the fifth. And then n to the third and n to the third makes n to the sixth. So even though problems can look nasty, it's really not that bad. Let's take a look at question number 20, and then we'll wrap things up. So start with the coefficients. 3 times 7 is 21. Then I'll go back and add up my exponents. So u to the fourth, u to the second makes u to the sixth. And then v to the fifth, V to the third makes V to the eighth. Okay, I want to throw in one more example just to kind of help clarify some stuff that's not on here. What if I had, let's say, 6x to the negative fourth times 3x to the negative 7. If I multiply my coefficients, I get 18. Add up my exponents, and I get x to the negative 11th. But if you recall, negative exponents can't stay negative. We have to change them to positive exponents. So that x to the 11th is going to move to the denominator. But that 18 does not have a negative exponent on it, so it can stay up in the numerator. And there's my final answer for that one. Now you may see these other problems like 21, 23, 22, 24. Those look a little bit different than what we've been doing. That's because we're going to use a different rule for that. So we just learned the product rule. Later on, we're going to learn the power rule and then the quotient rule. And the way problems look will determine which rule we're going to use. So hopefully you found today's rule, the product rule, very easy. And I want you to be able to just do problem after problem after problem very quickly with that. However, what gets challenging is when you have this rule and that rule and keeping them straight as to when it looks like this, you use this rule. When it looks like that, you use the other rule. So practice with what we're doing today with the product rule. And then next lesson, we'll try to keep it straight with what we're doing with the power rule. Okay? So if you guys have any questions, please feel free to email me or ask me questions in class, and I will see you guys real soon. Have a good one.